Hello everyone and welcome back to our channel. Hello everyone and welcome back to our channel. Today I'm going to tell you all about another exciting scratch animation. This time I'm going to animate a Ferris wheel doing the circular motion, but I tried to make find a Ferris wheel sprite, but I couldn't find one, so instead of making the Ferris wheel animation for doing circular motion, I'm going to make an animation of Earth rotating around Sun in circular motion and another unicorn rotating opposite to the Sun and Earth. So let us see the animation. See here, I use three sprites. One sprite for sun, which is going to stay fixed on its position. Another sprite for earth, which is going to rotate in anti-clockwise direction around the sun. And another sprite, unicorn, which is going to move clockwise around the sun. And the unicorn is going to stop after doing one revolution, and earth is going to revolve forever around the sun. So let us see the animation first. So I've made so it's this is the code for earth's circular motion. Let us first see the animation. See, completed one revolution. Now let's start the unicorn rotating. Okay, that's all for the animation. And let us understand what was the question for Ferris wheel animation. See here, I had the question that I have to make a loop for circular motion and use the move and turn blocks for circular motion rotating, and the challenge was to use trigonometric calculations. But one thing to note, the move and turn, I didn't actually use the move and turn operations for circular motion, as if I used only the move operation, then it will only increase the x coordinate, which will make the sprite move forward, the earth move forward and not circular. And turn will rotate in particular angle, but I am using the trigonometric radian system, so I'm not rotating by using directly the turn angles, because it actually didn't made it easier for me to make the trigonometric calculation. And I was supposed to adjust the speed of the loop to make Ferris wheel spin at different speeds. But I used only one speed for Earth's circular motion. The challenge was to use multiple cars for doing the circular motion. For making two different cars in a Ferris wheel, we see that the car one starting position is different to car two starting position. So the if I made the animation success in order to make this animation successful, I have to make place two different sprites at two different starting points. So for that challenge, I used a unicorn sprite and earth sprite. So unicorn is rotating, as we all saw that unicorn is rotating clockwise direction starting from this position, say starting from -200 0 position, unicorn's position, and earth starting point at 150, 0 starting position. So this challenge is met by these two sprites. So what logic I used to what logic I actually used to make these sprite rotate in a circular fashion. So here, in order to make the Ferris wheel actually a similar motion of Ferris wheel, I use the trigonometric coordinate system, also known as the uh, you might have heard it as a parametric equation form, where we all know that in a unit circle, if circle is divided into four parts, the starting angle is 0, and then after reaching 90 degree we are at pi by 2 point, then again reaching at 180 degree pi point, then again reaching to 270 degree or 3 pi by 2 point, and again one full circle is 2 pi radians or 360 degree. So in order to make a full rotation, first we need to look at how is the coordinates of x and y are changing. So this is the coordinate system we are using. In this example, this is a unit circle. So of the x coordinate of this unit circle is r cos theta, and y coordinate is r sin theta, and r is 1, so only sin theta and cos theta is written here. So in order to rotate in one first quadrant from 0 to 90 degree, what's the relationship between the x coordinate and y coordinate? So by relationship I mean to say that whether x coordinate is increasing or decreasing and the y coordinate is increasing or decreasing. Let us see it with the help of an animation. So here, in order to move the first coordinate, let this animation come back to the first coordinate. We are going to look that the x coordinate is going to decrease and y coordinate is going to increase. Yeah, again it has started. X coordinate decreasing and y coordinate increasing. And if we move further, then in the second half, the x coordinate is going to increase and the y coordinate is going to decrease. So we are coming back to the second coordinate again. So yeah, x coordinate increasing and y coordinate decreasing. So this is the one semicircle rotation pattern. But as soon as we go to the third and fourth coordinates, a similar motion is going to again repeat. Let us wait for almost in third coordinate. See again, in the third coordinate, x coordinate is decreasing and y is increasing. And in the fourth, again same pattern, x is increasing and y is decreasing, as in the same semicircle. But if I am using the coordinate system r cos theta comma r sin theta, then first I actually thought that I am going to use the repeat loop of changing the coordinate into 0 to pi, and then again repeating that same 0 to pi to make a second half rotation. But we are using the trigonometric functions in order to locate my point uniquely. So even if I use the range from 0 to 0 to 2 pi, then this is going to make a circular motion using only one loop, as cos theta and sin theta have unique values in all the four coordinates. So what so let us head back and see the function's logic. So here I've used for the let us see for one revolution what's the yeah, what's the code. I fix the starting position of unicorn at minus 200 comma 0 position. Then I made a variable for angle which is going to vary as our which is going to vary as our the program runs or as our position changes in the circular motion. So because I'm starting from pi, so I use the value of unicorn. You can think is as angle of unicorn to 180 degrees. So here is one caution. Scratch only uses the degree system and not the radian system. So I'm going to use for range, I'm going to set it to degrees and not radians as we usually do in mathematics. So how I'm changing the position of the sprite unicorn. So as I move, I'm setting the x coordinate to 200. 200 is my radius for unicorn's movement and using cos theta, that is r into cos theta, and theta is unicorn. So theta first for first loop, for first iteration of the loop is 180 degree. So it's 200 into cos 180 degree, which is minus 1 comma 0. And because it's 200, so it's going to be minus 200 comma 0, right? Where I have fixed the unicorn. Then I use for y coordinate, which is 200 into sine 180 degree, which is 0. So as I have used the set x and set y coordinate, so as this loop iterates in its range, it's going to change the position of sprite. I tried to use the go to x or go to y, but it actually just didn't work. So I used the set blocks. Then I update the angle theta by 180 degree, that is 180 plus 30 degree for next position. And I use the wait uh, I use wait for 1 second as because computer runs real fast, so that circular motion ends very fast and we are not able to track as angle theta is changing. We are not able to actually understand when angle theta is changing as it looks one uniform motion. So I have used because in order to turn 360 degree, how I set the range actually. I didn't use the range for theta, a unicorn range from 180 to 3 to again 360 degree. 180 plus 360 I didn't do. How I set the repeat how many iteration I am supposed to do. We all know we all know that one full circle means 360 degree movement and I am using 30 degree intervals, so I did for number of loops 360 degree by 30 degree, which is equal to 12. But scratch start is the iteration starting from 1 to 11 if I use the range 12. So scratch is going to say 1 to 11 only. So I have to increase one iteration from 1 to 12. In order to do 1 to 12 number of iterations, I have to set the repeat till 13. But in Python, it's opposite. In Python, the range is set from no, sorry. Range starts from 0 to the number, whatever number less than 1, right? But scratch starts from 1 to whatever the last number minus 1. So this will complete one revolution. Then what about if I want to do multiple revolutions? So for Earth, I used the variable theta. So you must be wondering why I used two different variables. Because Earth's starting position is different and unicorn's starting position is different. So as Earth has started from 0 degree and unicorn has started from 180 degree. So for tracking both of their motions smoothly, I used two different variables for tracking the angle. So here angle theta, usual notation I have used, starts from 0 degree, and the same way r cos theta, r sin theta movement. But here radius of the circle is 150 degree for Earth. So I'm gonna change same by same intervals. I'm gonna change by 30 degree and wait for us to see the motion. And here I've used the forever loop because Earth moves around the sun forever. For that reason, if I were to only play the Earth motion, see it's starting from 0 and rotating anti-clockwise. Okay, then we can see how unicorns moves. Oh, sorry, unicorn is also moving clockwise direction, anti-clockwise direction, but starting from 180 degree. As the problem of Ferris wheel actually posed to us, that for two different cars to make it a feeling of rotation, both the cars should rotate in the same direction, but starting position should be different. So this similar scratch animation actually compensates for the Ferris wheel problem. So thank you for everyone for watching this video till the end. If you like this video, please hit the like button. If you love this video, then please hit the subscribe button and meet you to a next and meet you all to a next scratch project. Bye bye. Take care.